What if we told you that NASA deliberately crashed a spacecraft into an asteroid? On September 26, 2022, NASA did exactly that, traveling millions of miles through space just to smash into a space rock. This wasn't some crazy experiment, it was humanity's first real test of protecting Earth from dangerous asteroids. The mission was called DART, which stands for Double Asteroid Redirection Test, and it worked better than anyone expected. Think of it like playing pool in space, where the cue ball is a washing machine-sized spacecraft and the target is an asteroid about as big as a football stadium. Today, we're going to break down every fascinating detail of this groundbreaking mission that proved we might have a chance at saving Earth if a killer asteroid ever heads our way. Understanding the mission. Let's start from the beginning. NASA has been worried about asteroids hitting Earth for a long time. After all, just ask dinosaurs how that turned out. That's why they created DART, their first mission specifically designed to see if we could knock an asteroid off its path. On November 23, 2021, at exactly 10:21 p.m. Pacific Time, DART began its journey. The spacecraft hitched a ride on a SpaceX Falcon 9 rocket, blasting off from Vandenberg Space Force Base in California. This wasn't just any regular space launch, it was a start of a 10-month journey covering millions of miles through space. The target wasn't picked randomly, NASA chose two asteroids that travel together. A bigger one called Didymos, which means twin in Greek, and its smaller companion Dimorphos. Didymos is pretty big, about 2,560 feet across, which is nearly half a mile. That's like 8.5 football fields lined up end to end. Dimorphos, the smaller one, is about 530 feet wide, roughly the size of 2 football fields. Here's why these asteroids were perfect for the test. They weren't going to hit Earth no matter what happened. It's like practicing your boxing moves on a punching bag instead of in a real fight. Much safer that way. The DART spacecraft itself was pretty simple, but in a clever way. Imagine a vending machine flying through space. That's about how big it was. It only had one main camera called Draco, which acted like its eyes. Draco helped DART see where it was going and took pictures for the scientists back on Earth. The spacecraft also carried a tiny companion, a small satellite called LISIACube, built by the Italian Space Agency. Think of LISIACube as a space photographer ready to take pictures of the big crash. The plan was straightforward, but incredibly difficult to pull off. DART needed to crash into Dimorphos at a mind-blowing speed of 14,000 miles per hour. That's like traveling from New York to Los Angeles in 13 minutes, but here's the tricky part. The spacecraft had to hit an asteroid that's millions of miles away and only about as wide as 2 football fields. Imagine trying to throw a dart at a moving dartboard that's as far as the moon. To solve this problem, NASA gave DART what they called SmartNav, basically a super smart autopilot system. In the last few hours before impact, DART had to fly itself because any signals from Earth would take too long to reach it. It's like if you were driving a remote-controlled car on Mars, by the time you tell it to turn left, it would already be too late. The big impact. After traveling through space for 10 months, DART finally reached its target on September 26, 2022. The whole world watched live as DART's camera sent back pictures of Dimorphos getting bigger and bigger on the screen. In the final images, we could see that the asteroid's surface was covered in rocks and boulders. Important information that would help scientists understand what these space rocks are really made of. At exactly 7:14 p.m. Eastern Time, DART slammed into Dimorphos. Scientists knew the crash was successful when DART's signal suddenly stopped, like when a phone call cuts off. Now, remember that little Italian spacecraft LISIACube? It had separated from DART 2 weeks earlier and was watching the whole thing from a safe distance, taking pictures like a space paparazzi. The impact was way more spectacular than anyone expected. When DART hit Dimorphos, it threw out more than 22 million pounds of rock and dust into space. That's like exploding 30 fully loaded cargo trains worth of material. This debris created a tail behind the asteroid that stretched for thousands of miles like a comet. The famous Hubble Space Telescope watched this tail for weeks as it changed shapes and grew longer. Before DART showed up, Dimorphos took 11 hours and 55 minutes to go around Didymos once, and NASA hoped the crash would change this time by at least 73 seconds. But what actually happened was much more impressive. Measuring the results. Scientists all over the world pointed their telescopes at Dimorphos to see what changed after the crash. What they found was amazing. After the crash, DART had shortened Dimorphos' orbit by 32 minutes. That's more than 25 times better than what NASA hoped for. It's like aiming to move a car 1 inch, but actually moving it 2 feet instead. But that's not all. Recent studies using powerful computer programs showed that DART did more than just push Dimorphos. It completely changed its shape. Instead of just making a crater like a rock hitting sand, the impact actually squished and reshaped the entire asteroid. About 8% of the asteroid's material got moved around, and 1% got thrown into space. This told scientists something really important about Dimorphos. Instead of being one solid rock, it's more like a big pile of rocks floating in space, held together by gravity. Scientists call this a rubble pile. Think of it like a bag of gravel versus a single big stone. This actually worked in our favor because Dimorphos was made of loose rocks. It was easier to push around. The success of DART wasn't just a win for NASA, it was a win for the whole world. Space agencies from different countries worked together on this mission. Italy helped by providing LysiaCube, and Europe is planning to send another spacecraft called Hera in 2024 to take a closer look at what DART did to Dimorphos. Looking to the future. DART's success means we now know one way to protect Earth from dangerous asteroids. We can crash spacecraft into them to change their path, but there's a catch. We need to spot dangerous asteroids early enough to do something about them. The earlier we find them, the more time we have to prepare. That's why NASA is building a new space telescope called the Near-Earth Object Surveyor, set to launch in 2026. This telescope will use infrared light, the same kind of light that makes heat, to find asteroids that might be hard to see with regular telescopes. Scientists aren't putting all their eggs in one basket, though. They're looking at other ways to move asteroids too. One idea is to park a spacecraft next to an asteroid and let gravity slowly pull it off course. Kind of like using a magnet without touching it. Another idea is to use multiple methods together, like first hitting an asteroid with a spacecraft and then using gravity to fine-tune its new path. In 2026, Europe's Hera spacecraft will visit Dimorphos to see exactly what DART did to it. By studying the crash site up close and measuring things like the asteroid's weight and what it's made of, scientists will learn how to make future asteroid deflection missions even better. DART marks the first time humans have purposely changed how something moves in space to protect our planet. It's like we've finally learned how to play cosmic billiards, but instead of winning a game, we're learning how to save Earth. The mission showed us that when countries work together, we can achieve amazing things, even moving a space rock millions of miles away. While we hope we never have to deflect a real asteroid heading toward Earth, it's good to know we are getting better at protecting ourselves. Just like early humans learned to build shelters from storms, we're now learning how to shield our entire planet from space rocks. The universe is vast and full of potential dangers, but DART proved that we're not helpless against them. We are entering a new age where we can actually change the path of objects in space, and that's pretty incredible when you think about it. That's a wrap up. Thanks for joining us in today's video. If you're fascinated by space exploration and scientific breakthroughs, be sure to subscribe to our channel for more in-depth coverage of cutting-edge space missions. Keep looking up at the stars. They hold both our greatest challenges and our greatest opportunities.